Locating points accurately and precisely is a critical part of the geometry workflow. MicroStation and Bentley Civil software have options for precision input, but some are better than others for a civil workflow. MicroStation provides a powerful AccuDraw tool, but it does not think and respond like a civil engineer. While AccuDraw is very useful for locating offsets, distances, angles, etc., what if you need to locate a point at a station value? There are techniques you might be able to get this done with AccuDraw, but they're cumbersome at best. Ultimately, AccuDraw does not understand civil engineering and key ordnance such as stationing. For these and other reasons, you will come to appreciate the civil AccuDraw as a preferred alternative to the MicroStation AccuDraw for most civil work because it works more like civil engineering workflows. Combined with MicroStation snaps, civil AccuDraw provides a very robust precision input tool for civil engineering work. One thing to keep in mind is that MicroStation AccuDraw and Civil AccuDraw have a great deal of overlap and should never be used at the same time. It's one or the other. MicroStation AccuDraw should be disabled before enabling Civil AccuDraw. When civil geometry is created using Civil AccuDraw, the geometry remembers how it was created, including the Civil AccuDraw parameters. In this example, the geometry element is created at an offset and distance from the southwest corner of the building. The start of the geometry element is 150 feet from the building at a bearing of south 14 degrees east. The geometry element is 200 feet long in a due south direction. The exact same operation was performed using both MicroStation and Civil AccuDraw, and both resulted in an accurately placed geometry element. The difference is the additional intelligence captured when using Civil AccuDraw. Observe that the geometry created using MicroStation AccuDraw has manipulators and handlers to edit the geometry, but not the position of the geometry relative to the building. The geometry created using Civil AccuDraw has the same geometry manipulators, but also has manipulators for the offset distance and direction from the building, as well as a snap indicator at the origin. All of these manipulators can be edited just like the geometry manipulators. Civil AccuDraw provides heads-up prompting, making it very easy to enter values as you work. Civil AccuDraw can be used with both MicroStation drafting commands and civil geometry tools. If you are uncomfortable with the heads-up prompting, input can be made through a Civil AccuDraw window. Just press the down arrow key on your keyboard to open the Civil AccuDraw window. When the Civil AccuDraw window is open, the heads-up prompting is not displayed. Other heads-up prompting related to the tools being used may still appear. You just need to close the Civil AccuDraw window to return to the Civil AccuDraw heads-up prompting. Ordnance define the coordinate system used by AccuDraw to locate points. MicroStation AccuDraw works with either a XY or rectangular coordinate or in distance and direction, which is polar coordinate system. Civil AccuDraw supports additional ordnance including absolute X, Y, and Z coordinates, station, offset, profile offset, and slope. Civil AccuDraw supports virtually any combination of the ordnance into a coordinate system. The ordnance can share a common origin, or each ordinate can be calculated from separate origins such as a distance-distance coordinate system, where both distances are measured from a different location. The most commonly used ordinate pairing are already set up, but other pairings can be defined as needed. The delivered ordinate pairings for a 2D plan are listed on the screen. The pairings for a profile view are also listed on this screen. Shortcut keys direct Civil AccuDraw to perform an action such as establish an origin, rotate the compass, or lock a value into an input field. Here are several shortcut keys you will find very useful when working with Civil AccuDraw. As your Civil AccuDraw skills increase, you may want to explore additional shortcuts to unlock even more power in this tool. Rotating the compass is one of the most common activities, and there are many different ways to Rotating the compass is one of the most common activities, and there are many different ways you may need to rotate the compass. Three of the most common are rotate quick, rotate the compass parallel to an existing element, or rotate the compass oriented to north. The O shortcut works a bit different in Civil AccuDraw than it does in MicroStation AccuDraw. In Civil AccuDraw, you press the O key and then data point to the new origin. Civil AccuDraw should not be enabled all the time. You should enable it when you need it to locate a point and then disable it when you do not need it. Leaving it enabled all the time when working with civil geometry tools can cause confusion because both the civil geometry and the civil AccuDraw may be storing the same data. Angles and directions are in degrees, minutes, and seconds format. They must be delimited by either a colon or a caret to designate degrees, single quote for minutes, and double quote for seconds. Horizontal geometry can be created using a traditional PI-based approach, where PIs are located, connected by tangents, and smoothed with arcs between the tangents. The complex by PI tool is very efficient for this type of geometry layout. This method does have its drawbacks though. The geometry must be designed continuously from the beginning to the end. Also, the locations of the PIs must be known. In many complex design projects, it is not possible or practical to design continuous geometry from beginning to end. You must design geometry in localized areas where the constraints exist and then connect those geometry segments in areas that are less constraining. The OpenRose technology geometry tools provide a robust set of tools for all your geometry needs. The tools are grouped by General, Line, Arc, Complex, and Modify in the horizontal geometry task menu. Notice that many of the geometry tools have a small black arrow in the lower right corner of the icon. This indicates additional related tools. Click and hold your left button on your mouse to display the additional tools. All of the tools displayed are similar in function, but each has a slightly different option. For example, one tool might be a simple arc, where another is a spiral arc-spiral combination, and another a taper arc-taper combination. Typically, the bottom tool in the list has all of the options. In this section of the class, our focus is on line, arc, and complex tools. The chain commands toggle on the feature definitions toggle bar. Chains together are commands. For example, when using line between points tool and then the chain commands toggle is enabled, each consecutive line automatically starts at the end of the previous line. When enabled, some commands can automatically determine base elements to use during calculations. For example, arc between elements will choose the two most recent elements and set them for base elements to construct its fillet. The heads-up prompting guides you through the parameters required to create the geometry. For example, line between points tool prompts you for the distance between the beginning and the ending point, or in other words, the length of the line. However, you have to be alert for additional prompts that are accessed by pressing the left and right arrow keys on your keyboard to cycle through the prompts. When you're using the line between points tool, there's a prompt for both distance and direction. If you use your right arrow key, you can switch between the two. There's also times where you can use your up and down arrow keys to cycle through settings in a field like trim/extend options. By default, the arc tools prompt for the radius of an arc. However, the arc can also be defined using degree of curvature. To enter a degree of curvature, you just put the letter D in the radius field as a prefix. This toggles between degree of curvature mode and radius mode. As discussed earlier, feature definitions define how geometry appears and other parameters. It is a good practice to always assign a feature definition to all geometry elements. The best way to do this is use the feature definition toggle bar. Set your feature definition before placing any of your geometry. When you want to use the feature definition of an existing element, use the Match Feature Definition tool. Select the tool and then click on an existing element. The feature assigned to that existing element becomes the active feature.